Hello everyone, welcome to Tuteetute. In our last session, we have completed the hydroelectric power plant. Now, in this session, we will study the thermal power plant. Okay, so thermal power plant we have to study. We know already thermal power plant means the input is steam for this. Okay, so let's have the general schematic diagram of this, and later we can understand in deep about this schematic. Okay, so how we have to construct this power plant. We have to understand about this power plant by understanding each and every part in this one. Okay, so we already know thermal power plant means input is coal for this. Okay, so generally we call as steam power plant. Okay, instead of thermal power plant we can call as steam power plant. So the input to the turbine is steam here. Okay, so anyway, this is the general schematic I have given. We have to draw all this diagram again, so to understand many of the points. Okay, so I will just explain you that, so just understand. Okay, so anyway, so this is thermal power plant, right? So in thermal power plant, what is the base, what is to be there in between means, so the boiler has to be there. So many of you may know this one. So how we have to generate the steam? So from the boiler. Okay, so we have to take one boiler. So from the boiler, so we have to generate the steam. So you have to generate the steam, you know. So that means boiler has to burn, right? Inside it has to burn. Burn means it has to combust inside. Combustion has to be done inside. So how it is possible means we have to send some inputs to this boiler. Which inputs you have to send? You have to send coal input and water input and some air input. Okay, so generally coal and water, these two are enough, but we will send air also. I will tell you why we have to send some air. Okay, so first we will take some coal. Okay, so I am just taking some coal input to this one. Okay, so coal input we are sending inside. So where generally coal will be there? In coal handling plant. Okay, so coal handling plant. Okay, so the block to block we'll understand again. First we'll understand the operation. So what will be there inside this coal handling plant? So everything we'll understand in deep about these things later. First we'll know the operation of this entire thermal power plant or steam power plant. Okay, so first try to understand all. Okay, so coal handling plant we have taken. So from coal handling plant, so we have to take the coal. Okay, but there will be ball mill we are using in between. Okay, so why we are using ball mill means, so we should not take the raw coal, right? Like rocky coal will be there, just like the strong coal will be there. Directly if you give all those things in the boiler, it will not combust properly, it will not mix properly, so will not get the proper output. So what you have to do, you have to crush that coal. Okay, crush means we have to make it as the powder. Okay, almost some powder. Actually there will be 3 stages of crushing. Okay, so from very big coal, raw coal, to the next level, that means a little bit of small stones like that. Okay, so we have to crush that. After that again we have to crush. What we are using for that crushing? So we are using the ball mills. I have just given only one here just for understanding. There will be many of the ball mills like that. Okay, so anyway, into that boiler we are sending the crushed coal. Okay, otherwise powdered coal we are sending inside. Okay, so powdered coal we are just taking that. Okay, and tell me, from where you used to get the coal? From where we used to get the coal means from the other parts of the states. If it is available in your state, from here only, from other parts of the states if you want. Otherwise from the other countries. We have to just take that coal. How you will transport the coal? Through the trains only. Okay, so in India we are preferring through the trains only, and there should be some connectivity of train whenever we are constructing one thermal power plant. Remember this. Okay, so I will ask you these things again, so you will get some more points about these things. Okay, so whenever we study about this coal handling plant, okay, so we have to send this coal into coal handling plant. So you may have observed something, whatever directly you have taken coal from the earth surface, so it is not a good one at that time. That means there will be some moisture for that coal. You can observe that inside the earth surface there will be some moisture, right? So whenever there is some moisture, so whenever directly you cannot crush that properly, the grains will be like that. So what you have to do, you have to drain that coal first. Whatever you are bringing, so in the trains you are bringing, right? So it may be wet or it may be dry, we don't know that. So we have to handle that coal for some days. That means we have to make that dry. Total it has to be dry. That means it should not have any water content inside. It should not have any vapors also. Okay, so like that we have to handle that coal. Okay, so that will be happening in this coal handling plant. Okay, so now that coal we are sending into the boiler. Okay, so boiler. So tell me, we have to get the steam in this boiler. Steam we have to get. How you can get the steam? So we have to send some water, right? So without water, by sending only the coal, it will not happen, right? So what you have to do? You have to send some water. Okay, so let's take some pond. Near to this power plant, we have some pond. Okay, so pond. Pond means so where water can be stored. Okay, so otherwise a river. So otherwise there will be nearby river or some canals will be there, right? So we have to take some of those things. Any some of the water is required. So near to the thermal power plant there should be requirement of some water. Okay, some water availability must be present there. Okay, understood, right? So now from here you have to take the water. Now tell me, directly if you take this water, so in this water there will be many of the other components. We don't know what will be there in this water. So what you will do is, we will just demineralize this water. Okay, so demineralization plant we have to use here. Okay, so demineralized plant. Okay, so demineralization of water we have to do here. That means whatever water you are taking here, that is not a mineral content water. Okay, demineralized, we are just removing all the minerals from that. Once you have taken the demineralized water, so now see what you have to do is, so we can directly send this water into the boiler, but see, cool water it is. Cool water it is. So what you have to do is, if you send directly this cool water, so the coal will be attached like that, and again it will become like rock solid again. So what we have to do is, we have to send hot water inside. Okay, so very hot water we have to send. At the same time, we have to increase the pressure of this water. See, one by one I am explaining. Okay, so inputs we are taking to this boiler. Inputs are, one is the coal, another one is the water. Okay, so we can give here water. This is the water. Okay, so another input we are taking, that is the water, and we should not send the cold water. If you just send that cold water, then automatically inside combustion will not be proper, then you will not get the sufficient steam. Understood, right? So that means you have to send hot water. At the same time you have to increase the pressure of that water. But suddenly from zero temperature, from some temperature here, or negative temperature of water here, maybe we don't know, right, what is the temperature, suddenly increment of water, increment of heat, it is not possible. So what you will do is, first you will increase the heat at low pressure. We will just increase the heat of this water at low pressure. Okay, so we will just take the low pressure heater. Okay, so we are just taking low pressure heater. So in low pressure heater, so the water can be heated at low pressure. Okay, so little bit of pressure we will apply on that water and heat will be increased. Okay, so in low pressure heater there will be heat increment will be there. Okay, so now little bit of more pressure started for this one, little bit pressure, and there will be some of the heat also. So what we will do is, next we will send into the high pressure heater. The same water we will send into the high pressure heater. Understood, right? So first we have increased some pressure, at low pressure we have heated, after that we are heating at high pressure. So what you have to do after that means, you have to take this water into the economizer. Okay, so we have to take into economizer. Okay, so I will just draw here, just see this one. So this is economizer. So economizer, to the economizer we are just sending that. So what will happen to the economizer means it will just increase the heat of that one. Okay, heat of that water will be increased. Okay, so understood, right? So heat will be increased for that water. Now you are sending that hot water into this boiler. Again, see, you can understand, right? Two inputs we have taken. One is the water, another one is coal. Coal we are directly taking here, and water we are sending by taking demineralizing that water. After that we have just increased the heat at low pressure and increase the heat at high pressure. After that, through the economizer we are just sending into that. Okay, so that is actually we are taking two of the inputs, but for good combustion, we need air also. Yes or no? For good combustion we need air also. There will be good combustion if you take the air. So what you have to do is we have to take some air. Okay, so we have to take some air. So from the atmosphere we have to take some air, but it is not directly that air. If you use this air, so atmosphere air will be little bit of less in temperature. So whenever you send this one, the boiler temperature, whatever it is, it may get reduced if you send normal. Okay, so air will be bit in cool, right? So if you send that, the boiler temperature may reduce. So what you have to do is you have to increase the air temperature, increase this air temperature by placing one air preheater. Okay, so we are just heating this air by placing air preheater. Okay, so air preheater. Okay, so air preheater we are just placing there. So that means into this air preheater we have to send the water. So we have to use some fans there. So that will be called as the FDs. Okay, so FDs means the fans. Okay, so which type of fans means forced draught fans. Okay, FD fans means those are forced draught fans. Okay, by using forced draught fans we are just sending that hot air, we are just sending the air into the air preheater. Now if output of this air preheater is hot air, we can understand, right? Hot air will come out. Okay, so just understand the procedure. Okay, so now we are sending all these things, three inputs we are sending inside. So there will be some combustion will be there here. So what will happen means, so output of this, what you will get output, the steam you will get as the output. But see, whatever steam you got here, so that is of high pressure. We have already increased the pressure here at high pressure, and whatever you are sending water inside, so up to here, whatever dark line I have given, that is water. Okay, so and I am just giving the dotted line here, that is of steam. Okay, so just understand like that. So now steam is the output of this. Now steam is coming outside. So once the steam is coming outside means we have to increase even the temperature of this steam also. We have to reach more temperature. Okay, so we'll study about all the temperatures, different temperatures, operating temperatures in this plant. First we will understand the procedure. Okay, so now steam is coming out. So what will happen to this steam means, so the steam we have to increase the temperature again. So what will happen means we have to place some superheater. Okay, so superheater we have placed. So whenever you have placed superheater, the steam temperature again increases. And up to the required amount of heat we have to send this. Now you got steam output there. Now this is our input. To the turbine. Okay, so here you got the input to the turbine. Now you can see one thing. For this thermal power plant, we have to control the input also, right? So that means it should be in our control. Then only we can control the generation. We can control. Input should be in our control. So we have to place some valve here. Okay, so some valves we have to place here. So valves. Okay, so we have to place the valves. So when valves are opened more, then more steam will go. When valves are opened less steam will go into the turbine. Okay, so we can understand we have to place one turbine over here. Okay, so turbine we have to place. So once we have placed some turbine, okay, so you can observe here which type of turbine we have to place. This is not water turbine, right? So what we are giving as input here? Steam is the input here. So in the turbine, so steam, this is a steam turbine. So in the turbine, what is the operating input here? Steam is the operating input here. Okay, so anyway, steam means this is at high pressure, high temperature, right? So the steam whatever you are collecting here as the input to this turbine, that is of high temperature and high pressure. So we have to use a very good turbine here which can withstand for the high temperatures and high pressures. Okay, so let it be, it is working properly. Now whenever it is working properly, so turbine shaft we have to connect for the generator shaft. Okay, so we have to connect to the generator rotor. So once the rotor is rotating, from that we can generate the three-phase supply. Okay, so three-phase power we can generate. So you may get doubt, is it possible to generate single phase or three-phase? What you are preferring? So generally three-phase power generation is preferable, and that too AC power. Okay, so AC power only we are generating, not DC every time. You can remember this. Okay, so AC power we are generating, that too not single phase. Three-phase we are generating. There are many advantages are there. Instead of generating single phase, we can go for the three-phase. Why we are going all these things? You will learn in the your machine subject, especially in the synchronous machines. Okay, so in synchronous machines you will understand about this generation in three-phase and generation in a single phase separately. Okay, so there are some topics where you can understand those things. Okay, anyway, here once you have generated three-phase power, we have to use some circuit breakers, right? Okay, so always we have to protect our system. So not only circuit breaker, we have to use the line isolators also. Okay, so line isolators. So I will tell you what are these line isolators. In power system only we will study this one. Okay, so we will study these line isolators. These are also protecting elements only. Okay, so just like our circuit breakers, we have to use line isolators also, and we have to send through the grid. Okay, so we have to send this whatever power generated to the grid. Okay, so once you have sent, that power we can use. Okay, so this is the circuit breaker and we have the line isolator. Understood, right? So anyway, we are giving a steam input. So we can understand generation is possible here. So forget about this generation. Okay, so this is, we don't want this all now. Okay, we have understood this already. We have separate topics for those. How generator is working, how circuit breaker is working, how line isolator is working, how three-phase power collection is operating. You can understand all those things. Okay, so but here in thermal power plant we have to understand what you have to do more for this power plant. Okay, so steam we are giving for this turbine, and tell me output of that steam, output of that turbine is also the steam, right? So we are sending the steam into the turbine at the tail race of that turbine. Tail race means end part of that turbine. Okay, so where whatever you are sending into the turbine for the rotation of the turbine, so something will come outside, right? So that steam only will come outside, and that steam is very high temperature and very high pressure one. So what you have to do, can you directly leave that like that to the outside? It is not possible, right? So if you leave means within 2 or 3 days only the entire area will be changing. Okay, so it is very high temperature and very high pressure. So what you have to do is you have to place the condenser here. Okay, so I will just show you. So the condenser we have to place for any of the turbine. Next to the turbine we have to place one condenser like this. Okay, so this is called condenser. Okay, so I will just write here condenser. So condenser, what it will do is it will just convert the hot steam into the water. The hot steam into the water. So through the condenser, the steam will flow like this. Whenever steam is flowing like that, the steam will be converted into the water. Okay, and there will be some pressure decrement and temperature will be almost of same. Okay, so but steam is converting into here water. Okay, steam is just converting into water here, but some pressure will be decreased here. Now also you cannot send this out outside. Now also you cannot send this outside. So we got some water here. So what you have to do is, so whatever water you got, you can just send this into low pressure heater again. Okay, so by using some valve here, we can just send this water into this low pressure heater, and we are just using this water, whatever water you are getting here, so that water we are just sending into low pressure heater again. So heat will be increased slowly, and again here high pressure will increase the heat, and again we will send into economizer, and again all these inputs. This is just like a feed water. Okay, so we can call this as feedback water or feed water. Understood, right? So this is feed water at the condenser output. Okay, from the condenser we have taken the feedback water, otherwise feed water. So we have just taken one valve. So how much water you need here, that much only we have to send, right? So we have taken one valve and sending into low pressure heater, and after that high pressure heater it can go. After that you can understand that. Okay, so anyway, so all the water whatever you are sending, everything you cannot use here, right? So some of the water we have to look back. Okay, so how much water is coming here, that much if we send here, same water only we are using every time, right? That means we have to change that water also. But for good combustion, okay, already steam has been generated here, and there will be some loss of water also. So what you have to do is, we have to add some more water to this. That means every time some of the feed water we will take, and some of the normal water from the pond we used to take. Understood, right? That means from the pond we will just demineralize the water, and after that send into low pressure heater, and in low pressure heater some of the other feed water is also there, and they both will mix. After that high pressure, after that we will get into the economizer. Understood, right? So this feed water is very, very important, and this water also will come. Okay, so and some of the other water will be there, and it is of very high temperature. We can understand water, it is just water only, but temperature has not reduced properly here. So what you have to do, we have to place one cooling tower for this. Okay, so we have to place cooling tower for this. Understood, right? So cooling towers are very, very important for any of the thermal power plant. Why means, if cooling towers are not present, then the entire area whatever near to that, some of the 2 or 3 kilometer circle, so it will become like very hot. Okay, so that is very dangerous to the our outside world. Okay, that's why we have to place some cooling towers. Okay, so cooling tower. Okay, so you may observe outside in the pictures also, you can observe there will not be even one cooling tower, there will be many cooling towers, at least of 2-3 like that. Okay, so according to the requirement, so there will be cooling towers. Okay, so you can observe that. Okay, so what will be there inside the cooling tower means, continuously water flow will be there. Okay, so if you observe one thing, cooling tower inside nothing will be there. Inside nothing will be there, only the surface. So there will be 2 layers inside. Okay, so just like, so I will just draw here first. Okay, so this is cooling tower. Okay, so this is of cooling tower. So for the cooling tower there will be nothing inside, but continuously there will be water flow is happening inside this. Okay, so just like throughout the cooling tower there will be water present every time, and we have to change that water continuously. Why means, cooling tower is just whatever you got here, hot water, we have to send those things to one side, and other side we have to send the cool water. So what will happen, the hot water will mix with cool water, and it will become cool, and it has to come to this other side. Okay, so the cool water will come. Okay, so where you can send, how you can send this water into cooling tower means, from this pond only we have to take. Okay, so from this pond only we have to take the water, some of the water, and send into this that cool water, and here from the condenser we will get the hot water. So here hot water will come. Understood, right? This is of cool water. So both will be mixed inside the cooling tower, and with less temperature, very less temperature, it will be coming out. So we will just send these things again to the pond only. Okay, so we are not just wasting that water. Okay, some of the water we are just using, and whatever remaining water we are just sending into that pond only again. So what is happening here? The water is very precious here. That's why we are just sending into that pond here. Understood, right? So generally you tell me, what is the need of this thermal power plant? What is the need of thermal power plant? So if you have hydroelectric power plant, then what is the need of thermal power plant? No need, right? So why we need thermal power plant means we don't have sufficient water. We don't have sufficient water, then only we'll go for thermal power plant. Otherwise, we would plan for hydroelectric power plant, right? So that's why whatever water you are using here, everything we are just maintaining again. Some water we are using as the feed water, some water we are using as cooling. We are cooling that water and sending into the pond again. Understood, right? So this is how water management we have to do here, and you can observe the boiler here. So what will happen to this boiler means, so inside the boiler steam will be generated. There will be many layers, okay? So I have not given actually. So there will be many layers. So where in these layers the coal will be placed, and we will send the hot water and hot air, so it will be continuously rotating and burning, right? We know already this. So the combustion is happening here in boiler. Combustion is happening, okay? So whenever it is combustion, so output of that combustion is the steam, okay? So you can observe here. So whatever I am getting here, that is steam, okay? So steam. So once the steam has been generated, do you think only steam will come out or any of the other particles will come out? So we are sending coal inside. Coal we are sending inside, right? So there will be some of the uneven particles, what we don't know also, okay? So some of the output of these things will come as, okay? So there will be two types of outputs will come. One is ash, okay? So bottom ash will be there. Okay, bottom ash, you can observe that. So bottom ash we used to call, okay? So bottom ash means the ash content which is of heavy ash, it will just come down and settle at the down. We can observe, right, the output of this. And some of the ash, what it will do is, that is fly ash, okay? So fly ash it will be. Okay, so fly ash also will be there. In this fly ash, there will be many of the flue gases. Flue gases means very hot gases. Okay, so there will be flue gases. That flue gases, we have to use the temperature. They are at very high temperature. They are coming from the boiler, right? So whatever temperature it has, so the flue gas is also having a same temperature. So the fly ash is having many of the flue gases. I am just writing here. So it has some flue gases. Okay, so flue gases it has. So what we have to use these flue gases means we will use the temperature. Okay, so how we can use this temperature means the flue gases we can send through the air preheater. Gases we are sending, okay? You may observe, okay? So there will be some tunnel inside. So through that tunnel, steam is going. Through the tunnel, steam is going. On that tunnel, flue gases will be passed like this. Okay, so flue gases will be passed like this. Whenever flue gases are flowing like that, then the temperature will be maintained constant. Okay, so little bit of improvement of temperature will be there. Understood, right? So what is the use of superheater? We have to increase the temperature of that steam. Now to maintain that, to increase the temperature, we are just sending the flue gases into that superheater on the pipeline. Okay, so on that pipeline, so if this is the pipeline, my hand is the pipeline, so inside this pipeline there will be steam going, and I will just send these flue gases like this. Okay, so whenever this gets heated, then automatically inside the steam gets heated. Okay, so that is what the idea. Not only that, whatever water you are sending inside here in the economizer, we are just sending some water, right? High pressure heated water we are sending here, and that water also we are just heating by using these flue gases. And not only that, the air preheater also, the air we are taking into some tunnel, and that tunnel will be heated using this flue gases. And After that you are getting these flue gases outside. Okay, so we are getting these flue gases outside. You can observe here the blue mark whatever I am giving, that is of flue gases. Understood, right? So now these flue gases are very dangerous. You can understand that, right? The outcome of this boiler, that is coming from the ash material. This is coming from the ash material. Some of the ash content is very heavy. That heavy ash will come at the bottom of that boiler, and the fly ash means which can fly, very less weight. Okay, so very less weight, generally it has to go in the outside, okay, atmosphere. So what we will do is we will just use that heat, and to heat the steam, to heat the water, to heat the air. Okay, so you can observe, right, this is very very important. The flue gases, how they are going means, first they are going through the steam, after that water, hot water, that is also okay. After that, so we are using the air. Okay, so through the air channel it is going. Okay, so now if it go outside, so it will be very dangerous. We can observe that, right? So what you have to do is we have to use electrostatic precipitator here. Okay, so electrostatic precipitator we have to use. So automatically, so some of the flue gases will go into this, not some, okay, so all the flue gases we have to send inside, and some will be automatically suppressed there in electrostatic precipitator. Then whatever is the remaining, so we have to send outside. Okay, so how we can send outside? By using some chimney. Okay, so chimney, this is called chimney. Okay, so this one you used to see the outside, whenever you see from the roadside to any of the thermal power station, you can see some of the gases are going up like this, right? Black color, something like. Okay, so what are those things means? Those are this from the chimney you are getting outside. Okay, this ash, that is nothing but fly ash, but many of the flue gases are suppressed here in this electrostatic precipitator, and that is also not much safe. Okay, that is also dangerous only, but they don't have any dangerous gases. Directly it will not affect. Okay, so for many of the years, if you take that air, okay, so there will be some issues you used to get. Okay, so that's why the thermal power plants we have to place away from, okay, so away from the human beings. Okay, so that means wherever humans are living, so we should not place over there. Not only human, so any of the things, if they are living near to that, means we should not construct this thermal power plant over there. Okay, so that is not at all a good thing. Okay, so anyway, we need power generation, so we need to construct this thermal power plant. Okay, so anyway, through the chimney, okay, so there will be outside we have to send, we have to send that. How we can send that? We have to use some fans. Okay, so there will be, we have to take that one, we have to take that gases and put outside. Okay, so that means very much force. Okay, we have to induce some of the force. So that is, we are using some gas, we are using some fans here, that is ID fans. ID fans means induced draught fans. Okay, so there will be two types of fans. There will be two types of fans in thermal power plants, that is, one is FD, another one is ID. ID means induced draught fans, okay, and FD means forced draught fans. Forced draught fans means we have to send into the plant this one. Okay, so the air we are sending into the plants using forced draught fans, and we are just sending the flue gases, the fly ash we are sending outside using that induced draught fans, otherwise you can call as smoke. Okay, so that is nothing but the smoke only. Okay, understood, right? So this is the complete schematic of our thermal power plant, and you can observe one thing. So whatever bottom ash you got here, do you think this is of safe? Do you think this is of safe for us? It is also not at all safe, very dangerous this all. So what you have to do is you have to take this bottom ash, and we have to handle this one. Okay, so handle means it should not put away to the outside, and whatever near to that entire thing will be damaged. Even the earth surface also may damage if the earth that means near to the fields, if you place this one, so it may damage our cultivations, whatever will be there. Okay, that's why we should not place all these things there. So we have to handle this. There will be ash handle plant. So in the ash handle plant, we have to handle this one, and we have to dump this one. Okay, so ash dump, in the ash dump. So wherever, so there will be no persons, there will be nothing to worry about that place. So we have to place those things. We have to send this ash into that ash dump. After many of the years, after like 20 or 30 years, this will become again coal. It may. Okay, so and with ash dump, in that ash dump, we will just give many of the other things also. Okay, so just it has to be good after many of the years. Okay, so ash will not be there. Ash will be converting into the coal material after some of the years. Okay, so that's how we have to understand this. Okay, so we are taking the coal, and coal we have mix, and crush that coal, and after that we are sending into the boiler. And not only the coal, we have to send some water also. After that we have to send some hot air also we have to send. Okay, so all these things will be sending inside, and there will be steam generation inside, and that steam we have to send to the turbine. So there we have to use steam turbines here. Okay, so anyway, about all these things we'll study. Okay, so what is demineralizer plant, what is low pressure heater and high pressure heater, so what is this pond. Okay, so what is the use of this cooling tower, what is the use of condenser, what is the use of which type of generator we are using, and similarly use of this flue gases. There will be some use of this flue gases, right? We are using the heat of that flue gases, and superheater, economizer, air preheater, electrostatic precipitator, and there are some fans, induced draught fans and forced draught fans. And we have to, before all these things, we have to handle this coal. After the generation of the power, there will be some of the ash will be coming down. So that ash we have to handle, and we have to dump that ash. Okay, so this is what complete analysis of thermal power plant. So you can observe the order, right? So order is so same inputs we have to take, that to which type of inputs we have to take, that is very, very important. Okay, so coal we should not take directly. So we have to mix that coal, and we have to remove all the contents, that means debris inside. So inside the coal there will be uneven particles, right? So there will be some iron particles inside, there will be some stones will be there. So everything we have to remove those things. Okay, so after that we have to crush that into the powdered coal, and that powdered coal we have to use here. Directly we are not using, and we can directly observe here water we are not using directly. So we are using that water and demineralizing that water. So there should not be any of the minerals. So now the question comes, whenever there is some mineral water here, mineralized water, that means some of the minerals are available in that water, then what will happen? So what will happen means that minerals will link with chemical reactions. Okay, so that minerals, whatever there in water, the chemical reaction may happen with the coal material. Okay, that means inside the coal there will be many of the other minerals, right? So they can mix with that, and we don't know what output will come at that time. We don't know, right? In this water what is available. So maybe by tomorrow the minerals contents will change here, by tomorrow mineral contents change here. That's why we have to demineralize that all minerals every time. Okay, so whenever you are sending inside, we have to demineralize those. Okay, so you may get doubt, the feed water we are not demineralizing, directly taking into low pressure heater. So whatever feed water we have already demineralized, and that water is converting into steam. Again that steam is converting into water here, and that water we are using already demineralized that water. Understood, right? So whatever feed water that is already demineralized, and that's why we are directly taking into low pressure heater. Otherwise, if you think that is mineralized, this has to be demineralized again, we can send through the demineralized plant also. So just understand, okay? So just understand this one. We can send through demineralized plant also. For example, if there is some leakage, you may guess, okay? So that means in the condenser, so there will not be proper handling of that water. Then you can send those directly into this water after cooling, okay? So you can send all the water into the cooling tower, and from the cooling tower you will send this to the pond, and from the pond you can take this one and demineralize that water and send into the low pressure heater, high pressure heater. You can observe, right? Low pressure heater, high pressure heater. After that, economizer, boiler. After that, superheater. After that, it's from the wall we have to send through the turbine. After that turbine we have to suppress that pressure. Suppress means we have to reduce the pressure, and heat has to be reduced for that steam, and steam has to convert into water, okay? So all this is happening in this condenser, and whatever output we can make as feed water, otherwise send into the cooling tower, okay? So this is what the complete analysis of this thermal power plant. And remember, some of the points are very important. They will just ask what is the order of the fly ash going, otherwise flue gases flow, okay? So the order of flue gases flow is first superheater, after that economizer, after that air preheater, okay? So this one they have asked many times, okay? And each one has its separate application. I will tell you, okay? So what is that application? So we have to discuss each and every part of all these things in our next session, okay? So this is what about this. So in our next session we will understand all the parts, okay? So different parts of this one. We have not studied about the temperatures, right? So what is the temperature maintaining, what is the pressure maintaining, which type of turbine we are using, which generator we have to use here, and what is the different applications of all these things, and why we have to use that type of fans also, okay? So everything we will study in our next session, okay? Thank you.